My name is Tyler Salazar, and today I'll be presenting on the fuel, gear, and the prop systems of the Seminole. Let's begin. Primarily, the fuel system in total provides for 110 gallons of total fuel, of which 108 are usable. There are no tabs to indicate fuel. However, there is a calibrated dipstick with the plane that can be used to determine the amount of fuel. The minimum octane grade of fuel is 100. There are also two drains located on the right of the fuselage, as pictured below, and at the low point of each tank, respectively. The fuel controls determine whether the fuel will flow from the respective tank, left engine, left tank, when on, zero flow, when off, and from the opposite tank, when on crossfeed. Now taking a look at the fuel diagram listed in the POH, we can see how some of the previous systems collaborate. Beginning with the selector valves, they determine which fuel cell uses them. There are also the fuel drains, over by the right side of the fuselage, noted by the quick drain. The two drains, located at the low points in the fuel tanks, are mentioned as the sumps, while being in a similar place as the filter that catches any impurities that may be present from flowing into the engine. Each side includes an electrically driven fuel pump for emergencies and startup, followed by the engine-driven fuel pump, which is the main pump used for fuel throughout the operation. The fuel servo controls the mixture and throttle inputs, while the transducer gives the fuel flow indication. The flow is then divided into the cylinders by the flow divider and distributed to the cylinder via the nozzle. Fuel is also made available to supply energy for the heater via the combustion heater fuel pump. It is also important to note that the fuel vents are inherently designed to be anti-icing. Moving from fuel systems to gear, the gear itself is a retractable system, which is hydraulically operated via oil in a typical tricycle configuration. The gear selector switch, as pictured above, determines the direction the hydraulic pump moves. The nose wheel is steerable up to 30 degrees based on rudder inputs and braking, and includes a gear centering spring to prevent shimmy. It also has a bungee system to reduce the steering effort, while also dampening shocks and bumps. The struts are operated by an air oil assembly. The main source used to operate the gear comes from the hydraulic reservoir, which will be seen in the next slide. As mentioned earlier, the system is predominantly powered through the hydraulics within the reservoir, the hydraulics being guided by the electric reversible hydraulic pump. The four various gear indications that can be seen in the cockpit as pictured in this slide are given based on the various limit switches and micro switches that trigger the gear pump to stop pumping based on the location of the gear. The gear is held in the extended position via downlock hooks and extension and locking springs that create tension to hold the gear in place. There is a mirror available on the left engine side that may be utilized for taxiing and to verify manually that the gear is down. There is also a squat switch that prevents the gear from retracting while on the ground by not activating the hydraulic pump until the oleo strut is fully extended, closing the switch. The emergency gear extension knob may be used in the event of hydraulic failure by releasing the hydraulic pressure, keeping the gear retracted. Here is a closer look at the electrical system used for the gear. As you can see, there are various switches for the left, right, and nose gear for their up limits, down locks, and other electrical mechanisms that verify the placement of the gear. The gear select will either provide current to the up or down, which manipulates the gear up or down as long as the weight on wheels relay, squat switches, and hydraulic pressure switch permit the current to move through. On the left, the gear up and gear down switches are elaborated in full. Depending on the input and the activation of the lock switches and hydraulic pressure switches, the hydraulic pump will be activated to move the gear and stop when reaching the appropriate setting. The propeller system of the Seminole can include either scimitar or straight blade types, and the diameter for each can vary. For scimitar blades, the minimum is 72.5 and the maximum 74, whereas the straight blade has a minimum of 72 and a maximum of 74. The system is a constant speed prop, meaning the system will work to vary the pitch of the prop to maintain a given RPM setting. It is hydraulically actuated via oil and is a full feathering prop. The props are also counter-rotating, meaning the left propeller spins clockwise and the right propeller spins counterclockwise. This eliminates a critical engine and provides balanced thrust when both engines are running. The Seminole prop system is equipped with a governor, which modifies the pressure to meet the set RPM settings and varies the pitch to match engine torque based on the flight conditions. The oil in the system is used to provide higher RPM settings and lower pitch, and the nitrogen pressure and spring assembly provide low RPM and high pitch situations, while also preventing overspeeding. The control quadrant of the prop consists of two blue levers, and depending on the location of the switch, forward being high RPM low pitch, and aft being low RPM and high pitch, will manipulate the governor to adjust the prop. The unfeathering accumulator is a device used that stores pressurized oil that is utilized when pressure is needed to move the oil into the prop and move it into a low pitch, high RPM setting. There is also a feathering lock on the plane, which prevents feathering at engine shutdown or at settings below 950 RPM. To the right of the text, you can see a depiction of the system from the airplane flying manual, describing how the prop may unfeather and feather. This image from Bold method is included to show how the governor system works to provide oil pressure to the prop and change the pitch. Observing the diagram helps understand the general idea in a simplified manner. Thank you.